Hello, and welcome to our Zoom class on percentages. We're going to do a review and do some problem solving and record this video. So in case we have some friends who couldn't join us today, if you're watching it on video, please be sure to pause when you need to in order to work out some of the problems there for yourself. All right, so we'll start by taking a look at some of our slides for today. So again, a reminder, we're here working on percentages. We're going to review the concepts related to percentages, what it means, and how to interpret those as mathematical sentences, and then do a little bit of problem solving. Okay, so we'll go back to the beginning. Percents give meaning by expressing amounts as parts of the whole. So we have two relationships here that you may have seen in one form or another. So the relationship or the ratio of the part to the whole is the percent over 100. That's what percent means, how many out of 100. Or you may have seen it as the version there on the right, that the part divided by the whole times 100% will give you the percent relationship there. So you've probably done these before, so let's try our hand at one of these in a real familiar setting. You earned 35 points on your last biology test out of 45 points. What is your percent score there? So take a moment, set that expression up, and come up with a calculation there. Okay, so the part was your part. What did you earn on the test? That's the 35 points. 45 was the whole. It's the total, the number of points available on that exam. So 35 divided by 45 times 100% gives you the percent score that you earned on that test, and that was 78%. Okay, we'll try one more before moving on. So there are 4.2 grams of iron in a typical 70 kilogram person. What is the percent by mass of iron? Again, try and identify the part and the whole and complete the calculation. So the 4.2 grams of iron is the part. It's the little bit that's inside of a person. So the whole is the person. That's the 70 kilograms. So we need to put the part on top, the 4.2 grams, the whole on the bottom, 70 kilograms. But wait, if you've noticed, our units don't match. When we do a percentage calculation, the part and the whole have to have the same units in order for those two units to cancel out and not be a part of our final unit, the percent. So we need to go back and either change the grams into kilograms or the kilograms into grams, or change them both if you want into some other mass unit. That's fine as well. But let's take the easy road and just convert one of them. So in my solution, I converted the grams to kilograms. So I have 0.0042 kilograms of iron now as the part on the top. The 70 kilograms of the whole person is my whole. It's on the bottom, times 100%, and we get 0.0060%. So that's us calculating with percent. But let's look at what it means. Suppose we know the percent, and then we're going to be trying to recognize that as a relationship of some kind. So let's look at different ways we have percents, either by volume, by number, or by mass. So we'll start with the percent by volume. Wine is 12% alcohol by volume. This means that there are 12 parts of alcohol for every 100 parts of wine, and the units of those parts in the whole are going to be volume units. And it doesn't matter what volume unit you use. You get to choose. So choose wisely, choose something that works in the problem that you have at hand. So for now, we'll just write down a few examples. So 12 milliliters of alcohol for 100 milliliters of wine, 12 gallons of alcohol for 100 gallons of wine, or if you wanted to do things in cubic meters, 12 cubic meters of alcohol for every 100 cubic meters of wine. You'll note that the part, the alcohol, that's the little bit that's inside the wine, has the numerical or the percent number related to it. And then the whole, the wine in this case, that represents the whole solution there, gets the 100. It's the whole part there. Percent by number, M&Ms are 15% orange. That means there's 15 orange M&Ms for every 100 M&Ms. We could also use other units related to numbers of things like dozens, 15 dozen oranges for every 100 dozen M&Ms, or 15 moles of orange M&Ms for every 100 moles of M&Ms in total. And lastly, the one that we'll probably see most often is percent by mass. So 65.1% of the mass of a bodybuilder is muscle. What that means, again, remember, you get to choose what mass unit makes sense for the problem to make your life easier. But we'll just put a few examples here. 65.1 grams of muscle for every 100 grams of body, or 65.1 pounds of muscle for every 100 pounds of body, or kilograms, 65.1 kilograms of muscle for every 100 kilograms of body. Just note that it's always the same unit for the part and the whole. Whatever unit you've chosen, it has to be the same on both sides. All right, some quick reminders before we jump into our problem solving. Percentages are a conversion factor, and they relate the part and the whole. And you'll note our strong man is back over here, reminding us that this is a key point here. This is something that's going to strengthen your foundation for problem solving. So if we can really get a hold of how to use percents as a conversion factor, we can put that in our toolbox and use it as needed in future problems. But our thinking frog is also here. There's a couple of things to remind ourselves about here. So the units are often identical, right? We saw they were both the same for both the part and the whole, but they refer to different materials. So for our problem solving, it's going to be essential to note both the unit and the material for our problem solving with dimensional analysis, so we can set those problems up numerically correctly and get things canceling that we want to cancel and keep things that we want to keep. All right, are you ready? Get your pencil and your paper and your calculator out. Again, remember, if you're watching this on video, to please pause if you need to work through the problems yourself. All right, our first example is a bag of M&Ms contains 35 orange M&Ms. How many M&Ms are in the bag before you eat any now? Take a moment, identify where you start, where you're going, make a plan, and then we'll work on solving the problem. Again, pause if you need to. So in our story of our problem, we start with, we're presented with 35 orange M&Ms, and our goal is to figure out how many total M&Ms are in the bag before we eat them. So I've written down my starting point over at the left and my total number of M&Ms over there, my goal over there on the right. And I recognize that those are two different things. So I am going to need somewhere in this problem a conversion factor between these two different materials. And that's what percentage is. It's a conversion between parts and whole. And we have that information from previous slides. So we can do this in one step. We'll use our percent information. 15 orange M&Ms equals 100 total number of our M&Ms of all kinds. So that's how we're going to use that percent information. We've translated it into something that looks like a conversion factor, like we've been using in other types of problems. So now we can use that unit and material information to help us set that problem up right side up. So here's our solution, right? Note that we've written 15 orange M&Ms and 100 total M&Ms. And to make the decision which one went on top, we just looked at our units. And our units include the material as well as the number that goes with it. So orange M&Ms is what we started with, so we'll put orange M&Ms in the denominator on the bottom, and our 100 total M&Ms then goes on the top. So we have 233 total M&Ms in our bag. Okay, let's try one more. A bodybuilder has a mass of 120 kilograms. What is the mass of his muscle in grams? Okay, so again, identify your starting point and where you're trying to go. we'll make a plan and work through solving it. Again, pause if you need a few more minutes to work through this on your own. So we start with what we have. A bodybuilder, he or she has a mass of 120 kilograms, and we're trying to find out the mass of muscle in grams. So that is my goal, grams of muscle. Again, note that those are two different materials. So I know that somewhere in my plan, getting from kilograms of body to grams of muscle, I am going to have to probably use some kind of conversion factor. Percentage is what we have available to us to relate those two different kinds of materials. But the other tricky part is that those are two different units. So let's look at our percent information. It can take us from where we start, kilograms of body. It can take us to something about muscles, but it has to be in those same units, in kilograms. So we can take our percent information that we looked at previously and use it as our conversion factor. But we're going to need the second conversion factor to get us from kilograms of muscle to the desired unit of grams of muscle. So we needed two steps in this problem. One bit of information we learned from before, and the second one is one of those prefixes that we had to have memorized. Okay, and with that in mind, we can now set up our dimensional analysis problem, let the units do the work for us. Right? Just make sure that we're writing down both the unit, the kilograms, and the material. Is it muscle or is it body? So that we can align our problem solving properly and end up with the proper units of grams of muscle. So 78,100 grams of muscle. So that's our percentages review and problem solving session. Thank you for joining me, and we hope to see you real soon.